Hi everyone, hope you're okay. This is part 2 of the indices tutorial. So today we'll be going through negative and fractional indices. If you have no idea what I'm talking about, you will have to go and watch the first video that I did, which is the introduction to indices. So if you just click the link below, or I'll try and tag it somewhere around here. Before I go ahead, if you find this helpful, give it a thumbs up and also subscribe if you'd like to see more content, and share this with someone who you know needs help. Okay, let's go. Again guys, my email is at the bottom, so if you have any questions or anything that you'd like me to cover. I'm moving on to a higher GCSE topic. It's fractional and negative powers. So I only have 2 rules. The first one is for the negative powers. So it says a to the power of minus n equals 1 over a to the power of n. Again, a can be any random number, so in our case we'll use 2. So if we have 2 to the power of minus 3, substituting a equals 2 and n equals 3. Into the right hand side we have 1 over 2, which is a, to the power of n, in our case, which is 3. Just remember that n is not minus 3, because the formula says a to the power of minus n. The n would just be 3, not minus 3. I'll just do another example. So this formula works for any number, no matter how big it is. So let's say we had a bigger number like 203 to the power of minus 14. We would do the exact same thing. So in this case, a is 203 and n is 14. So we'll just substitute that into the right hand side. So we'll have 1 over a, which is 203, to the power of 14, which is n. N is 14, not minus 14, just one big thing to look out for. And that is it. So you'll probably be expected to remember this formula. It won't be in the formula booklet, but as long as you remember with negative numbers, we're just putting it under 1. So the next rule is for fractional powers. It looks a little bit more complicated, but again, it's just a matter of substituting in the numbers for the letters. It says a to the power of n over m equals m root a to the power of n. I know the font doesn't make it very clear, but we can imagine some brackets around here. We're not doing m times the square root of a. We're actually doing the m root of a. For example, let's say if we had 2 to the power of 3 over 4. We are just substituting a, n, and m. So in this case, a is 2, n is 3, and n is 4. We'll start off by substituting the m, which is the 4, and we do the 4th root of a, which is 2. So it's the 4th root of 2, and we put that in brackets and put all of that to the power of n, which is 3. This isn't the same as doing 4 times the square root of 2. We're actually doing the 4th root of it. 3 would be the cube root, and 2 is the square root, and etc. So it basically means there's a number that we've multiplied by itself 4 times in order to get 2. So it's just the inverse of putting something to the power. You're not expected to work this out. It will usually just mean to simplify this. So if you've meant to simplify it, that is it. If it asks you to solve it, it's probably on a calculator paper. So you'll have your calculator, and there's a button on your calculator which does this function for you. I'll insert a picture somewhere on the page so you're familiar with it, but it depends on your calculator. We'll try with some different numbers. We have 14 to the power of 5 over 6. It's exactly the same thing. So in this case, 14 is a, 5 is n, and 6 is n. We're just substituting that into the right hand side. We'll do the m root of a, so it's the 6th root of 14, all to the power of n, which is 5. If we're simplifying, this is fully simplified. We wouldn't be expected to solve it. But the most common one that you'll find is a half. I'll do a good example with that. So let's say we have 100 to the power of a half. This is very nice because as you substitute it in, you begin to see why this works. We're just going to substitute in the values. So in this case, 100 is a, n is 1 and m is 2. As we can see on the right hand side, we're going to do the m root, so it would be the 2 root of a, which is 100. In other words, this is just the square root of 100, and it's to the power of n, and in this case n is 1, so it's to the power of 1. Nice and easy. So as you see it like this, it begins to make sense. Anything to the half is just finding the square root, and that is because when you substitute it into the formula, we have the 2 root here, which just means the square root. Something has been multiplied by itself 2 times to get that's 10. So this would just be 10 to the power of 1, which is just 10. If you do see a half, it usually will be something that you know how to solve. We'll go through some examples now using these rules, and hopefully it makes things begin to make more sense. These examples are exam questions that I've just found dotted about somewhere, so it will give you an idea of what you're expected to solve. But again, this is a higher paper, so don't be disheartened if you don't know how to solve some of them or you're finding some of them a bit tricky. We have the 3 questions here, and I'll also leave the rules on the right hand side here for you. A couple of things before we go ahead. One thing to remember is to deal with the coefficients separately, as we did in the first video. You would have to put, for example, in the first one, you would have to do 24 to the power of -4, and then you can use the index law for x squared to the power of -4. If you don't have an idea what I'm talking about, I will link the video again down below, so you can go and have an extra practice at that and then come back, and this should be a bit fresher in your mind. You can pause the video now, have a go by yourself, and I'll run through the answers now. If you're not confident, don't worry, hold on and we'll go through it together. The first one that I'm going to do is 36 to the power of -1/2. If we look at the rules here, we can see that it is a negative fraction. This means that we're using both of the rules. So there's 2 ways that you could do this. You could deal with the fraction and then the negative separately, or we can do it all together. So I'll do it all together first so you can see how it works. So 36 to the power of -1/2 equals, well, if we substitute this into the negative power formula, we would just have to do 1 over a to the power of n. So in this case, a is 36 and n is 1/2. So we're actually doing 1 over 36 to the power of 1/2. Doing it like this makes it make a lot more sense. So we'll continue to simplify that further. So we have 1 over 36 to the power of 1/2. We're now going to substitute 36 to the power of 1/2 into the second formula here. Our a is 36, n is 1, and m is 2. So we would be doing the 2 root of a, which is 36, to the power of n, which is 1, which gives us 1 over the square root of 36, which is just 1 over 6. So the other way that you could solve this is by doing 36 to the power of 1/2. And as we found here, it's just m, which is 2, root a, which is 36, to the power of n, which is 1, which is just 6. So if we have 36 to the power of 1/2, we can just do 36 to the power of -1/2 would be 1 over 36 to the power of 1/2. But because we've already solved 36 to the power of 1/2, we can just substitute this answer 6 into the denominator. So it would be 1 over 6. Now, no method is better than the other. They both give you the answer, so just do whichever one feels most natural to you. Okay, let's move on to the next one. The next one says simplify 24 x squared to the power of -4. So as I said earlier, you have to deal with the coefficient first. Again, you can deal with them separately, then put them together. It's up to you. I'll deal with them together. So 24x squared to the power of -4 equals, so we have to do 24 to the power of -4 multiplied by x squared to the power of minus 4. Now there's different rules for both of these because they both look different. So this one on the right has an indices. So as we learned in the first video, if we're putting a power to another power, we multiply them together. But for this one, we have to use the first rule here. So 24 to the power of minus 4, we would do 1 over a, which is 24, to the power of n, which is 4. And we're multiplying that by x squared to the power of minus 4. So that's x to the power of 2 times minus 4, which is minus 8. If you'd like me to do a video on negative numbers, comment below, let me know, and I'll be happy to do that. You can leave it separately, but you can multiply them together so it's one fraction. So the answer would be x to the power of minus 8 over 24 to the power of 4. And the last one is probably the easiest one. Simplify y to the power of minus 2 multiplied by y to the power of minus 3. So this is using the first index law that we did in the first video. If we have y to the power of minus 2 multiplied by y to the power of minus 3, we have to add the powers together. So that would be y to the power of minus 2 plus minus 3. So again, that's another negative number thing. If we're adding a negative, we just take away. So this is actually y to the power of minus 2 take away 3, which would be y to the power of minus 5. Now we have this expression that we can simplify using the rules that we have. So y to the power of minus 5, we would be using this first rule here. A is y and n is 5. So y to the power of minus 5 equals 1 over a, which is y to the power of 5, to the power of n, which is 5. And that would be our answer fully simplified. I have a summary here just for us to take away and to remember. Just remember the rules and watch out for negative fractions. So the negative fractions would be like the first one that we did, when it's a combination of both rules. You can just break it down into 2 parts if you find that easier, or just start by dealing with the negative and then you can deal with the fraction once it's in the denominator. The second thing to remember is the first index laws that we did. So again, if you've not seen the first video or you feel a bit rusty on it, I would just go back to that now. Use the resources that I've put in the folder. They do help a massive bunch, so you're able to practice. And the third thing to remember is to deal with the coefficients. So as we did in the question here, and as we did in the first video, just remember that if you have a coefficient with your variable that's raised to a power, remember to deal with the coefficient. So you still need to raise the coefficient to the power. But we've made it to the end. Again, I have some resources. So I've made an AQA indices paper with past exam questions. I noticed that a lot of the past exams had questions from like 1983 or something. Not that long ago, but just in general, they were older questions. So I've made a paper with the newer spec questions with indices, and it's off AQA because I know there's a lot of resources for Edexcel. Speaking of Edexcel, there's a paper here for indices by Maths Made Easy. I'm not sure if it's the same as the Maths Genie one, but I'll link it down below so you're able to have a go at it. And just a reminder that my email is here, so again, if you do have anything that you're struggling with, send me an email. I'll be happy to go through things with you. Thank you for watching the video. Please give it a thumbs up if you found it helpful. Leave a comment, subscribe to my channel for more content, and share this with someone who you know needs help. And I'll see you next time. Bye.